exponents. This I can rewrite as the 2 is going to stay in the top of the fraction, the 3 is in the denominator, and then I can kick this x to the 1/3 down here. So you're just going to look at this. Is there anything that's going to make this quantity come out undefined? Well, anytime you try to divide by 0, that's when you get your infinity or undefined. Well, 3 times what will give me 0? Well, if this is 0, because 0 to the 1/3 is still 0. So it is undefined when x equals 0. Let me go through that again. If I have 1 minus 2 divided by 0, 2 divided by 0 is infinity, or undefined. So I'm looking for an x value that makes this denominator equal 0, and it happens to be 0. So I've got an undefined. So I've got 2 critical points. One where the derivative equals 0, which means this is either a max, a min, or a horizontal plateau. This is either a cusp or a vertical plateau, because it's undefined at 0. So let's see what we've got. We'll make our little number line graph. And I've only got the 2 critical points. I've got the 0, and I've got the 8/27. So I just need to know what's happening before, in between, and after. I know the 0 is the undefined or infinity, whichever one you want to write down. Here, the 8/27 is where the derivative actually came out 0. So go type in the derivative function, because we want to know whether the derivative is positive or negative in between these key values, because that tells us everything we need to know about the original function. So I will type in the 1 minus 2/3 x raised to the negative 1/3. Table set. I want to see at 0. I'll start there. Before and after the 0. Let's see. Point. I don't know how big 8/27. I'm going to go change this to 0.001 just in case. All right. There's my error. After the 0, I'm negative, so it's negative in here. Before the 0, I'm positive. So that means the function went up and it went down. So I've got some kind of a maximum with an undefined derivative. That's a cusp. So I got a maximum cusp here. And then here, go back to my table set. I'll have it start at 8/27. Table. I better see a 0 there. I do. After it, my y values are all positive. So that means the graph went down, then went back up. This makes this a minimum. Should be getting good at those now. All right. 2 more. One algebraically, one graphically. Going over here. Oh, there it is. Yeah, negative exponents. Okay, I'm going to start a new page. Okay, example 3. F of x equals x to the 5/3 plus 5x to the 2/3. Okay, we want to find critical points on f of x and f prime of x. Oh, I forgot that part, didn't I? Yes, I did. Oh, good thing. Forgot my critical points. Hold on. Here. Critical points on f prime of x. Now, we're not going to make the table for this part. We're just going to find them. So I need the second derivative. And so I'm going to do derivative of this. So the derivative of 1 is 0. And the derivative here, I'm going to bring down the negative 1/3, multiply it by the negative 2/3. That's going to give me a positive 2/9. X to the subtract 3/3, that's going to give me negative 4/3. Okay, so I've got to set it equal to 0 and see if it's undefined. Where was I? Oh yeah, here we go. So, I want to know when this equals 0. So first thing I'm going to do is divide by the 2/9. 2/9. Divide by the 2/9. So that gives me x to the negative 4/3 equals 0. So that makes this 1 over x to the 4/3 equals 0. If I try to flip this, look at what happens on this side over here. I get x to the 4/3 equals 1 over 0. That's infinity, that's undefined. There is no solution that makes the second derivative equal 0. But there is a solution that makes it undefined. What's going to make 2 over 9x to the 4/3 be undefined? What's going to make this denominator 0 is an x value of 0. So I do have the undefined at 0 here. So that means there's something going on the derivative graph at 0, a cusp or that vertical plateau. Okay, finished that one. Now back to this one. Make sure I finished writing it down. Let's see. Well, I don't know how easy that was for you to go back and fix. Sorry. Here I am. Okay, that was the problem. Okay, so derivative. 5/3 x subtract 3/3, that's going to leave me with 2/3, plus multiply down, I'll have 10/3 x subtract 3/3, that's going to leave me with negative 1/3. Okay, we want to know when it equals 0 and if it's undefined. With this negative exponent, we are going to have the undefined. Well, let's go with the 0 first. Okay, I would factor out the 5/3, and you can factor with negative exponents. You take out the smaller of the two, and the negative 1/3 is the smaller one. So we are going to take out a 5/3 x to the negative 1/3. So the 5/3 is gone. To see what's left, when we take this out, we divide it out. And when we divide, we subtract exponents. So what I'm actually going to do to figure this out is take this 2/3 and subtract a negative 1/3 that I took out. So think 2/3 subtract the negative 1/3 that I took out. That becomes plus a positive. 2/3 plus 1/3 is 3/3, 1. This just turns into x to the first. And if you want to check yourself, multiply it back in. When I add this 1 to the negative 1/3, I better get the 2/3 back, and I do. 1 plus the negative 1/3 is 2/3. Okay, plus I had 10/3 divided out 5/3. That's going to leave me with a 2. And the x to the 1/3 is out. So now it's set each product equal to 0. So 5/3. Actually, make it a positive exponent. Does that equal 0? And when does x plus 2 equal 0? Here's the easy one. X equals negative 2. So critical point there. Think about this. Is this ever going to equal 0 here? Not a chance, because when I flip it over, I get 3 x to the 1/3 over 5 equals 1 over 0. There's my infinity. No solution here. But this does help me right here with the undefined. Is this function ever going to be undefined? 5/3 x to the negative 1/3 times x plus 2, undefined. Again, it's when your denominator equals 0. I don't know why I didn't write it with the over. X to the 1/3. So what value for x is going to make this whole denominator equal 0? That's a big fat 0. So we've got two critical points, negative 2 and 0. Make the little number line graph to identify what they are. Okay? Negative 2 was when the function equaled 0, the derivative. So that means this is either a max, min, or horizontal plateau. The 0 is when it was undefined, or infinity. So we've either got a cusp or a vertical plateau. Only 2 options there, 3 options here. We need to know what's happening in between to tell what they are. That's when you grab your little handy-dandy calculator, type in your derivative equation, and check. So 5/3 x raised to the 2/3 plus 10/3 x raised to the negative 1/3. Again, I'm going to have the table start at negative 2 and look before and after. So table set. Start at negative 2, and you want a very small increment. You don't want, well, this one's, you don't want to jump past the 0. You don't want to put like 5 in here and check what's happening, because you need to jump past this 0 here. But I'm good with what I've got. So at negative 2, there's my 0. After the, or actually before the negative 2, well, in here, I've got a negative. On the left-hand side, I've got a positive. So that tells me the function's increasing, decreasing. So I know this is now a max. I'm checking to see whether this is a cusp or a vertical plateau. So I got to put in the 0. And I'll look after that. Okay, I'm back to positive. So it went down and back up. So that must be a cusp, a minimum cusp to be specific. Cusp is the important part there. Minimum, not so much. Okay, and then the second part is to find critical points on this graph. So I use the second derivative to do that. So the second derivative, multiplying the 2/3 down, that's going to give me 10/9. X, subtract 1 from here, it's going to give me negative 1/3. Let's see, plus, actually, it's going to be a minus 10/9. Minus 10/9 x to the negative 4/3, and I want to know when that equals 0 and when it's undefined. So I'm going to factor first, do the 0. So again, which one's smaller, negative 1/3 or negative 4/3? And smaller just means it's, think about a number line. If you're farther to the left, you're smaller. So on a number line, the negative 4/3 is the smaller of these two because it's farther to the left on the number line. So we're going to factor out 10/9 x to the negative 4/3. So I'll have a 1 left there. And again, subtract the exponents. Start with this one, subtract this one. So think, negative 1/3, subtract a negative 4/3. That becomes plus. So negative 1 plus 4 is a 3. 3/3 is a 1. That's going to give me an x. Minus, take all of that out. I've got a 1 left in its place. And I want to know when this equals 0. Again, no negative exponents. So if I rewrite that, I've got 10 over 9x to the 4/3. I want to know when that equals 0, and I've already seen this twice now. I know there's no solution here. The only thing I can get is an undefined out of this. Here, x minus 1 equals 0. That happens when x equals 1. So I've got a critical point here. The derivative equals 0, so it's a max, a min, or horizontal plateau. Now as far as undefined, I'm just going right back to here and say it's going to be undefined when this denominator is 0. So I'll have 10 divided by 0 for undefined. That's going to happen when x is 0.